So since morning we are hearing about the generative AI, then MongoDB, Elasticsearch is the gold sponsor. So let's dig down into the one use case that we implemented at the Morningstar. So brief introduction about myself. So I'm engineering manager at Morningstar and I'm having total 15 years of experience in technology landscape, okay, and I'm AWS certified as well. So Morningstar is a investment financial services firm, and we are heavily using the cloud services. The use case that we are talking about in next 10-15 minutes is basically the migration of one of our important service to the cloud, and that is the central search service. So in Morningstar, we are having multiple products and we are having a central search service team, which is led by me. So wherein we have certain challenges in that particular migration. So to migrate all on-premises infrastructure to AWS along with the architecture modernization. So this search service is basically using the Apache Solar as a search engine, which is the legacy search engine that we have replaced with the AWS OpenSearch. So with that project like this, this project is go live in the Q3 2023 and it is successfully done. We migrated all of our client. So during this migration phase, how we replace our legacy search engine with the AWS services that I am going to discuss, and the major focus in the AWS OpenSearch service that we have used. So these are the some business challenges that we are trying to fix along with this migration. So we were using warning cache on the on-premises that we replaced with the CloudFront cache. Also the service that we are holding, which has 16 million calls per day, and that is one of the key factor along with this migration we have to achieve. Then the next is the Solar query search result and the OpenSearch query search result must be the same. So these are the some business challenges that we have to address along with this migration. So this is the Solar statistic. So Solar is a legacy search engine. It is the OpenSearch which is getting used. So this is the 10-year-old application that we were using. So within this application, if you see, we have master-slave architecture wherein we have one master node, which is the master, what we call it the master, which is the index writer, and we have the read replica, so slave Solar. So total we have 16 Solar on the live environment and 16 on the DR environment. So to support the 60 million calls, this is the legacy Solar search engine which we were using since last 10 years. And the performance that we are meeting with this legacy search engine was like the indexing for the per minute we are able to index 50K records, and the search response was in 100 to 500 millisecond. So this is the existing on-premises legacy search engine. And we try to replace this with the OpenSearch. So during this migration, when we started with the initial configuration for the OpenSearch, so this is the by default configuration by OpenSearch. When we try to launch any cluster or the domain for the AWS OpenSearch, this is the initial configuration that is provided by OpenSearch. So with this, we observe certain challenges, like the response time was very, very slow, and indexing speed and the search response both are slow. If you see in the previous slide, herein we are getting 50K record per minute in Solar, and response is 100 to 500 millisecond. But when we go with the OpenSearch, we didn't meet the performance, like the indexing speed reduced from 50K record to 10K, and even the search response was reduced from like 100 to 500 millisecond to the seconds. So to meet this, these are the challenges basically. So when we migrate our legacy search engine to the OpenSearch, then indexing speed was very, very slow. Search response was also so slow. And there is another problem. Whenever we are indexing around 70 to 80,000 records into the OpenSearch, around 50 to 53,000 records get deleted. So that is one of the major problem that we face. And even the solar, when we are loading, so this search engine was holding around 60 million securities, and to load that all 60 million security, solar was taking 24 hours, wherein OpenSearch initially it takes 40 hours. So we face these major challenges. Then to troubleshoot this, we have taken multiple approach. Like there is some APIs which is provided by OpenSearch. So basically the bulk insert, wherein instead of committing single record to the OpenSearch, we can insert a bulk request into the OpenSearch. So in which we can, let's say, we can put insert index around batch of 10K, 20K into the OpenSearch instead of single commit. So we change our implementation from a single commit to the bulk insert. Also, we implemented a multi-threaded approach. So here is, if you see previously, we were using the single thread, and we able to index only the 10K record per second. So we added the bulk insert, so we use the bulk API of OpenSearch, and we added the multi-threading. So with that, per minute we are able to insert around 100K records. And even if you see, we change our configuration of the cluster. So, default configuration, that is, with default we are getting the 5 primary roads and the replica of each. So index get divided into that many shards. So we replace that, which we read some of the AWS blog, and we come up with this particular configuration, wherein we change 6 data node, 3 master node, and we only come up with the 2 primary shards. So if you go here we have the 5 primary shard. So that we replace with the two primary shard. And with this configuration, we get the optimal performance. So here is the conclusion, like the overall indexing time of 60 million securities, that we are able to load it in the 24 hours, that now we are able to load it in the almost 8 hours. And response time is also get improved from like 25 to 200 milliseconds. So this is one of the use case that we implemented using the AWS OpenSearch. Yeah, thank you. If you have any query.